Hi, just before I start, I'll just show my student ID card. So my student ID number is 34645631. Let's get into it. So hi, my name is George Farmer and welcome to my Assessment 2 presentation on Topic 5, Geometric Thinking. So what is geometric thinking? Geometric thinking is all about understanding shapes, spatial connections, and how we can change or move shapes using transformations. It involves recognizing patterns in shapes and spaces and applying mathematical rules to manipulate these shapes. A key tool in geometric thinking is the Cartesian coordinate system, which provides a grid-based way to locate points in space with x and y coordinates. This system is essential because it lets us apply transformations and accurately observe their effects on shapes, making it the foundation for exploring geometric transformations. So geometric transformations. Building on this, geometric transformations are there are four main types of geometric transformations: translation, rotation, reflection, and enlargement. Each transformation changes a shape in some way, like moving, flipping, or resizing, while keeping certain properties such as angles and proportions intact. Here the Cartesian coordinate system plays a critical role as it helps track each change with precision, making these transformations easy to visualize and apply in real-world scenarios. So translation. What is translation? So translation shifts a shape to a new location without changing its size or orientation. Imagine moving a triangle across a page. Each point of the triangle moves the same distance in the same direction, which is straightforward to track on a grid. Rotation. So rotation turns a shape around a fixed point called the center point of rotation by a specific angle. The shape keeps its size and distance between points but changes orientation. For example, rotating the square 90 degrees around its center moves each point, yet the square remains the same. Reflection. Reflection flips a shape over a line, creating a mirror image. If you flip a shape over the y-axis, the image appears on the opposite side, but the same size and form. This transformation is particularly useful for creating symmetry. Enlargement. Enlargement changes a shape's size based on a scale factor and a center of enlargement. This transformation keeps the shape's proportions but adjusts its size. A scale factor greater than 1 enlarges the shape, while a factor between 0 and 1 reduces it. The role of the Cartesian coordinate system. So returning back to the Cartesian coordinate system, it's essential for tracking these transformations accurately. Divided into 4 quadrants with positive and negative values. The grid also allows us to plot shapes, apply transformations, and clearly observe their effects. For instance, by plotting points on the x and y axes, we can measure distances, rotations, or scale changes around the origin and visualize these changes in real time. This accuracy is crucial for understanding geometric thinking and practical applications in fields like design engineering, and architecture. Measurement and its connection to geometric thinking. Another important connection in geometric thinking is measurement. Measurement is deeply connected to geometric transformations, especially of shapes and space. It involves determining length, area, and volume, which are fundamental for comparing shapes and understanding how much space they occupy. Knowing accurate measurements is essential to maintain proportions when working with transformations like enlargement. For example, when enlarging a shape, you must apply distance accurately to ensure the shape remains proportional. Problem solving and its reasoning in geometric thinking. Geometric thinking also ties closely to problem solving and reasoning. Many geometric problems require a series of logical steps to find solutions. This skill is essential when applying geometric concepts to practical challenges like determining or how to move or transform shapes to fit into a given space. For example, if you're designing a floor layout, reasoning helps you place and transform shapes within that layout so everything fits together. This area of reasoning encourages us to use geometry practical and helps us approach spatial challenges in a structured way. Conclusion. In summary, geometric thinking is a broad skill that includes understanding and manipulating shapes through the transformations and measurements. Tools like the Cartesian coordinate system make this possible, while measurements, problem solving, and reasoning enhance our ability to apply geometric ideas in real life situations. Whether in design, construction, or analysis, these skills enable us to visualize, calculate, and solve complex spatial problems effectively, connecting geometric thinking with everyday practical use. Thank you.